Okay. Who wants to know what the answer is? I'm not going to tell you. However, how about we discover it? Would you like to do that? Okay. I want to share something with you before we do that. Just so we can see if we even need to do this lesson at all. I mean, do we need to do this lesson? Do we need to go through this process? I want to show you what answers you all had as a class. I had 6 people who chose answer choice A. I had 5 people who chose answer choice B. I had 0 who chose C, and I had 7 who chose answer choice D. How many correct answers do you think there are on that sheet? One. There's 1 correct answer. So do we see a need to go through this lesson? Okay. There's obviously something that we need to learn from this, and that's what we are going to discover today. Now, I want to remind you that in the past couple of weeks, what we've been doing is we've been talking about and we've been measuring volume and mass, right, of various objects. Now what we're going to do is we're going to take that and we're going to apply it to one of our physical science objectives, okay? The first objective that we're going to be looking at today is comparing the masses of reactants and products of a chemical reaction. What is the root word of reactant? What is the root word? React. What that means is in a chemical reaction, there are things that are reacting with each other. What do you think they're called? Reactants. So we know that reactants are those things that react with one another to create a what? Product. A product. Talking about taking the mass of these reactants and comparing the mass of the reactants to the mass of the product. Are you with me?
Yes,
okay. That's what we're also going to do is we're going to predict outcomes, and then we're going to actually conduct investigations to answer our testable question, okay? But what were the 2 things that actually reacted with one another? I want hands, please. Alexis?
The tablets in the water.
The seltzer tablets in the water. I want you to record that on your paper, because we're going to do the same activity that Carl did and discover what the answer should be. How does the mass compare? I'm going to put this on the balance. I've got my balloon, and I've got my water bottle with water, okay? And I can see that the mass of my apparatus before the chemical reaction takes place is 154 grams. I think I'm going to tell you what my answer is when I'm done?
No.
Probably not, because you need to discover that, right? Partner A, you are the one with the longest hair. So we're going to break our seltzer tablets into pieces. And then your partner is going to hold open the mouth of the balloon. And what are you going to do with the pieces of seltzer tablets? You're going to put them inside the balloon, okay? You will stretch the balloon over the mouth of the water bottle, and you're going to shake your balloon to let your seltzer pieces fall into the water. And do we have a place on our student worksheet to record that initial mass?
Yes.
Very good. What do we need to make sure we include with our measurement on our paper? We need to include our unit of grams. Very good. Now be very careful with the balloon. We want to make sure that we don't put any punctures into the balloon. What I want you to do before we finish conducting this investigation is make a what? A hypothesis. So on your paper where it says make a prediction about the mass after the chemical reaction, I want you to answer this using a complete statement. The question again is, will the mass of the product be greater than, less than, or equal to the mass of the reactants? Okay, so we have our predictions written on our paper. Are we ready to find out if our prediction is supported with evidence?
Yes.
Okay, now I want you to hold the balloon up. Partner A, the same person, hold the balloon up and shake the pieces into the water. Do you notice that maybe a chemical reaction is occurring? Are they coming out? And I want you to put your apparatus back on the balance. Okay, put it back on the balance. Make sure it's on. Make sure it's on. measure, go ahead and measure the mass of yours. Okay, and I want you to go ahead and record the mass of your apparatus now that a chemical reaction has occurred. What are we noticing here?
It's
Okay. Okay, we're noticing that our mass tends to be the same. Now, let's talk about why this may seem a little bit strange to us, okay? Whenever we put a liquid, that is water, and seltzer tablets that are what? Are they liquid?
No,
They're solid. And we call those the what? Go back to our objective. We're comparing the mass of the reactants. Those are the reactants. Whenever they reacted with each other, all of a sudden your balloon filled with not a liquid or a solid, but a what?
Gas.
A gas. Do you see how they reacted to produce something that is a new substance, right? That gas is the product of that reaction. Well, whenever we masked that again, we saw there really was no change of mass. That's weird, huh? And so I'm wondering, why is that? Why is that? Does anyone have any ideas? Alexis?
They might have stayed the same because it's the same. It's still the same object, just in a different form.
Okay, that's an interesting idea. Do you notice how I'm still not giving you an answer? Don't you love when I do that, Brad? What are you thinking?
Nothing's like added to the product or something in it.
Okay, we didn't add anything physically, and we didn't physically take anything away. We discovered, I think, what the answer should have been to the DOS. Are you wishing that you could change your answer? Kinda? Raise your hand if you think you wish you could change your answer on that. Okay, well, maybe I'll give you that opportunity, but what I want you to do first is I want you to research a little bit to find out the reasoning behind it. Okay, I think now we would state a different claim on our DOS. I think now, have we gathered some evidence here? Have we gathered evidence from an activity and investigation? Let's find out what reasoning might be behind that evidence to support our claim. I want to go ahead and have a discussion with you to talk about what are some of the main things that you pulled out of that research. Because it doesn't do us a whole lot of good to do an investigation and say, yes, okay, the mass stayed the same. The mass of the reactant stayed the same as the mass of the product. Boom, we have our objective. Don't we need to understand why?
Yes.
Yes, we need to have an understanding of why that is. And so let's talk about what are the main things that you found in your research. What kind of reasoning behind that did you find, Taylor?
For the first paramagnetic system is considered, and if any given system that is closed or contained, meaning that matter is not able to escape.
Okay, can you restate what she said for me, Brett? What is she talking about there when she said that any given system that is closed or contained, meaning that matter is not able to escape?
Matter stays constant.
Conservation of matter.
The law of conservation of matter, very good. Somebody tell me what the word conserve might mean. When we talk about conserving energy, when your parents say, turn off those lights and conserve energy, turn off the water, you're wasting water, we need to conserve it. What are they trying to say, Xander? Are they trying to tell you to use more?
No. They're trying to tell you to use less of it.
So that you can do what with it? You can save it, right? So when we think about the law of conservation of matter, they're saying that in a closed system, the mass of your reactants, when a chemical reaction occurs, that mass is saved. It stays what? What was your word? It stays constant, okay? And so what we're going to do now is we're going to do a little bit of a post-assessment on that objective to make sure that we absolutely did master that objective. Okay. remember what our results were before? And you didn't know this, but I was actually using your DOS as a pre-assessment to see how much do they really know so far. I want you to look at these results. These are the results that we have now for that same question. We have one person, let me do this in a different color. One person who chose A. We have one person that chose B. We have 15 people that chose C, whereas no one chose it before. And we have one person that chose D. Now, are we going to discuss this? Obviously, because we want to make sure that 100% of us understand our objective and that we can apply the knowledge of our objective to these type questions. Do you think one student may have said 195 grounded? Yes, ma'am.
I think the reason why they chose their answer is because they probably, from 200 grams, they probably subtracted 5 from 200 grams.
And what was 5 grams? What was the significance of the 5 grams? Mass of the 2 seltzer tablets by themselves was how many grams? 5. And so do you think maybe a common misconception was that whenever the seltzer tablets were put into the water and a gas was created, possibly the person who chose A thought that what? That the gas was what? Escaping, possibly, or when the seltzer tablets went into the water and a gas was created, do you see the seltzer tablets anymore?
No.
So do you think maybe that person thought that maybe they just what? Maybe just disappeared. What did we learn in the law of conservation of matter? We learned that matter is never destroyed or created, right? Y'all, what if you would have had a hole in your balloon when you were doing your investigation? How would it affect your results? How would the mass compare to the, how would the mass of the product compare to the mass of the reactants if you would have had a hole in your balloons? Why is that?
Because the air of the little substance.
The gas?
Yeah, the gas of it, it's like going, it's getting out and it's not gonna be the same.
Okay, and we can't really get the gas like this and bring it back and put it on the balance, right? It would have escaped. Does it mean that it disappeared?
No.
No, it just means that we're not able to contain it in order to measure the mass of it. When we're comparing the mass of reactants to the mass of their products, is the mass going to be greater than? Thumbs up if you think it's going to be greater than. Okay? Do you think the mass is going to be equal to? I want to see your thumbs. Do you think it's going to be equal to? If you don't think it's going to be equal to, put them down. Okay? Raise your thumb up if you think it's going to be less than. If the mass of the product is going to be less than. Okay, good. It looks like we cleared up those last few misconceptions. How does this question that I just read to you, that's number 2 on your post-assessment, how does that differ from our original testable question when it simply said, will the mass of the product be greater than, less than, or equal to the mass of the reactants? I'm going to get Brett to help me with this one.
It has to do with the balloon, if there's no balloon there.
Okay.
And then that one has to do with the product.
One thing that I did want to go back and address is, notice that we started with a testable what? Question. That's where every scientist begins. They start to wonder. Remember, everything starts with curiosity, and that leads us to pose a testable question. And then we make what? We make hypothesis statements based on that testable question. We are thinking like scientists. Is it okay if our hypothesis is not correct? Yes. It's just a prediction, okay? It's just a prediction. That means we learned even more. Was it important that we investigated to explore our hypothesis to see if it was supported or not?
Yes.
Yes, very good. Was it important that whenever we stated a claim on our post-assessment, was it important that we had gathered evidence and the what behind the evidence? The reasoning behind the evidence. And that helped us to come up to a what? What is the very last thing on our poster? It helped us draw a conclusion about our objective. Okay, it helped us master our objective today. Very good. Any questions? All right, very good.